made up of the skeletal muscle making part of the pelvic floor that urethra goes right through. So when those muscles contract, it squashes that tube that's in there, pinches it off so that urine does not flow through. It's a little different between the male and the female system. One, because there's this big blob in between the two sphincters in the male system. And this is actually a gland, the prostate gland. That'll come up again when we get to the reproductive system. So that's in two systems, I think. Which we don't have that in the female system. So females do not have the prostate gland. And another difference is the urethra in the male system is a lot longer because it runs right through the center of the penis, which is obviously absent in the female system. All right, let's talk about how micturition actually occurs. So while the bladder is filling up, the urinary bladder is filling up, this balloon represents our urinary bladder. It's at this relaxed state. It's just filling, so urine's trickling in through the ureters into this bladder, and it keeps swelling, getting larger and larger. While this is happening, the internal urethral sphincter just stays stimulated and constricts. It pinches it off. It's doing that all on autopilot. You don't think about it. You can't control it anyways because it's smooth muscle. The external urethral sphincter, until I brought it up, you weren't even thinking about it, and it was also stimulated. So remember, skeletal muscle, you have conscious influence on when it contracts and relaxes. But that doesn't mean you always have to consciously think about it. Right now you've got lots of skeletal muscles that are contracting and relaxing without you thinking about it. The ones involved in breathing, the ones involved in keeping you upright in your seat, right? Or the ones when your head starts going back and then you shake and bring it forward, which I said a few of you guys do today. So those are all subconscious, but you can consciously control it. So while your bladder's filling, you're stimulating the motor neuron that controls that skeletal muscle. Remember, skeletal muscle will only contract if stimulated by its motor neuron. So you have to keep stimulating that neuron, but you're not doing that consciously. It constantly just gets stimulated, and both sphincters stay contracted, pinching off the urethra, keeping urine from leaking out. This is during the filling stage. All right, now let's go ahead and invoke the micturition spinal reflex. So this reflex, involved in opening those valves and letting urine come out, is all done through the spinal cord. It does not involve the brain. Step one. Stretch receptors fire in the wall of the urinary bladder. So as the urinary bladder is filled, you put more and more urine in it, that bladder stretches out. And there are stretch receptors embedded in the wall that monitor the degree of fullness. So once it gets to a certain level of fullness, those receptors fire. Send action potentials to the spinal cord. Right? It excites parasympathetic neurons, and one of these neurons will inhibit the somatic neuron. Okay? It inhibits the neuron that's stimulating the external urethral sphincter. You've got to get that external sphincter to relax, which means you've got to turn that neuron off. So you can inhibit that neuron that just kept firing, so it's no longer firing, which will cause that external sphincter to relax. At the same time, you stimulate smooth muscle in the wall of the urinary bladder. So you just relax the external sphincter, and you contract the muscle in the wall of the bladder. That bladder's got a lot of muscle in it. Squeezes down on its contents, raising the pressure inside that bladder. And that pushes the internal sphincter open to that higher pressure. Remember, the external sphincter relaxed because we inhibited that somatic neuron. So now both sphincters are open, the bladder is squeezing down on its contents, that urine is going to leave the urinary bladder out through the urethra. Micturition has occurred. Okay, everybody got that done? All right, let's look at a diagram. So in this state, we've filled up our urinary bladder with urine. Those stretch receptors fire. They got stretched from filling up the bladder. Sends a message to the spinal cord. And we've got an interneuron in here that inhibits this somatic neuron, so we're no longer stimulating the skeletal muscle to contract. The external sphincter relaxes. At the same time, we stimulate the smooth muscle in the wall of the urinary bladder to contract, raises the pressure inside the bladder, stretching open the internal sphincter. So now both valves are open. This higher pressure pushes that urine out of the bladder through the urethra, and you empty the bladder. So what's missing from here? Nothing? We're all good? Move on? What's that?
Your decision, like the person deciding.
Yeah, where's my decision in all this, right? Because if this was the whole story, every one of you would be wet in here right now. Right? But we learned how to sort of override this reflex. Right? When you're only, say, a month old, you don't have the neural connections to override this. And when this happens, it just happens and goes. And it seems to go more often right when you put a fresh diaper on, or even worse, like between the old diaper and the new diaper, and then the urine just goes everywhere. And okay, so there's enough of that. So, but as you get older, you start to get the neural connections, and you start to recognize when the pee is coming. Right? And so you get that feeling of, wow, if I don't do something, then that urine is just going to pour out, and then I'm going to be wet, and then I get a rash again, and it's super uncomfortable, and it smells funny, and my dad got upset, my older sibling makes fun of me, and it's bad news. And then you have all this psychological problems because you haven't been fun of. But you develop that ability to override this inhibition. Right? You can't control the internal sphincter, but you can override that inhibition to keep this neuron firing, to keep that external sphincter constricted, and to hold it tight so that urine does not leak out. And then these receptors adapt. They say, okay, we're quite ready yet, it's not a good time, and then it cuts off this reflex. And we got to go ahead and let it fill up a little bit more. And then it fills up some more, and it stretches the receptor again. Whoa, let's try and do this, and then you can cut it off. And then the time between those sort of feelings of having to empty your bladder gets shorter and shorter and stronger, and eventually it's going to have to come out. All right, questions about this? Yes?
What happens on the flip side when, like, elderly use?
So yeah, there's a few things that go on. You can lose the ability to override the inhibition, so that's more neurological. Those muscles can get weakened, so you're not able to actually pinch off the urethra. So there's a few things that can go on to lose the ability to hold it. Yeah.
Does your bladder lose elasticity over time? Like if you stretch it out too much, does it?
Yeah, I'm not sure. It has an amazing ability to stretch, though. It can get enormous if needed. Don't go for that, but you know. Anything else? You guys got it? All right. It's a good time to switch gears. All right, so you have a lab tonight. I'll see you across the way. You guys can start collecting data and working on your group projects. If you're a Monday lab person, then I will see you Monday. We'll keep talking about the renal system.